The common package contains code which is reused in a variety of different classes and functions. In this part of the tutorial, we will learn about many different Kotlin language features which are designed for sharing code in an intelligent and efficient way. Topics covered include extension functions and properties, abstract classes, the open-closed principle, object singleton, and coroutine dispatchers. Before we write the code, let's talk about the open-closed principle. The OCP is a relatively confusing concept, but I will try to explain it in the clearest way I can. To give you my own verbal definition, which we'll break down later, any commonly reused software entity which is expected to change should have a fixed public interface and a way to change its implementation. In order for that particular definition to make sense, there's a couple things that I need to unpack. Firstly, when I say software entity, I'm generally speaking about a class or a function, but it could be a few other things. So, let's examine what I mean by public interface and why I argue that it should be fixed if it's commonly reused. By public interface, I am not speaking of a Java or Kotlin interface specifically. Instead, I mean any publicly visible aspect of a class or a function. Since this is an Android tutorial, let us take the example of the activity class. An activity fits my requirement of being commonly reused and expected to change over time, so it is a perfect case to think about the OCP. Every subclass of activity must include the onCreate function, which is a part of the public interface which it makes available to classes which reference it. The reason why we want this public interface not to change is very simple. Suppose that the Android platform developers suddenly decided to deprecate and remove saved instance state bundles from all lifecycle functions. Because this public interface is used by pretty much every Android program around, this platform update would break everyone's code. What I mean specifically is that all activity subclasses in all codebases which have not removed this parameter would not be able to compile. So this is why I am talking specifically about commonly reused software entities like activity, and why it is important that their public interfaces change as little as possible. Since we've established why fixed public interfaces are really important, the next question is simple. How do we then provide a mechanism or way for the implementation of the public interface to change? Well, it turns out that Kotlin gives you many options to solve this problem. Rather than explain them all verbally, I will teach you how to use them in code as we build this application. Right-click on the common package and go to New Kotlin File or Class. And this is actually going to be an abstract class, which they don't give an option for here. So what we're going to do is type in base logic. We will add in the abstract keyword. Unfortunately, I don't have the time to explain the difference between an abstract class, an interface, and plain old inheritance in this particular course. This is something I go into and explain very clearly in my other video courses. But what I will do is explain why we're using an abstract class here instead of an interface. The reason why we would want to use an abstract class is for situations when we want to share behavior. So for example, we'll be writing a function stub or abstract function, which I want to be shared across any class which inherits from base logic. And I also want to share a variable, but this particular variable will have to be protected as opposed to public. And if we were to try and do this using an interface, then necessarily that particular value would be public. We're also going to use a generic type, so I'll show you how to do that. So the syntax for a generic type is to just use angle brackets, and then you could type quite literally whatever you wanted between those angle brackets, but my suggestion to you is to not use something which is already used, hence why I'm using this all capitals event. Now, if it doesn't make sense what we're doing here, it will make more sense when we write the classes which inherit from base logic. Let's go ahead and finish this off. To briefly explain the intent of this abstract class, Basically, I'm saying that I want a set of classes, the ones which will inherit from base logic, all of which will have this function on event. In other words, these classes will handle events from the user interface. And then as we'll see, we're going to use this job object, which comes from the coroutines API, as a way to cancel child coroutines and also to make each of these logic classes as its own coroutine scope. I'll explain that when we get to that particular part of the tutorial. Right-click on the common package and create a new Kotlin file, which is just going to be a plain old file, and it's going to be called extensions. Kotlin's extension functions and extension properties are among my favorite features of the language as a whole. Without getting too technical here, extensions allow you to employ the open-closed principle, which states that software entities should be open for extension but closed for modification. If that doesn't make sense, don't worry about it. It's kind of a confusing definition, but it allows us to add new functionality to existing source code without having to modify the original source code. Now, this particular file, extensions.kt, is kind of like a replacement for static utilities that we might have used in Java or something like that. It's really just a place where I stick utility code which is used across the application. Let's write our first extension function to see how this works. The purpose of this particular extension function, obviously it will be used within activities, is really just syntactic sugar. It's a way to make it so that I don't have to type out toast.makeText and supply this message, toast.lengthLong, and .show. Instead, in the activity where we'll be using, activities I should say, where we'll be using this particular extension function, we can just type makeToast, give it whatever string we want to display, and it's handled like that. By making it an extension function of the activity class, I can use it seamlessly in any activity. Let's write another much uglier utility extension function. The purpose of this ugly little function here is to take the elapsed time of the given puzzle which the user is currently working on and to attempt to convert it into a value based on minutes and seconds, or a string to display based on minutes and seconds. Now, if it takes the user longer than an hour, then we end up just displaying like a generic more than 5959. Now, if you think this code is ugly in Kotlin, I challenge you to write it in Java. Now, for beginners, this might not make sense intuitively, but it's important to understand what this is referring to. This is actually referring to the long object, which we will be calling .toTimeOn. That might make a little bit more sense when we actually get to using this particular extension function. There's only one more extension we need to add, and it's actually going to be an extension property this time. So what I'm doing here is I'm hitting Alt-Enter on this particular red thing, and then I'm going to hit Add Remaining Branches. Going to hit Alt-Enter again to import R. These are obviously string resources. That's one thing we're not going to be writing by hand. So hopefully what you've done is you've gone and grabbed the source code for the starting point, which includes things like string resources. Right-click on the common package again, and we're going to create a new Kotlin interface, which is going to be called DispatcherProvider. This interface is very small. What we'll do is we'll write the code and then I'll briefly explain what it does. Now, unfortunately, I can't briefly explain what a coroutine context is, but I can explain the purpose of this particular class and how we're going to be using these coroutine contexts. So in most situations, most of the work that we're going to be doing within coroutines land is going to take place on the main thread or the UI thread. Now, with that being said, there are a few operations like writing to a file which we don't actually want to occur on the main thread, and that would be a situation where we're going to provide the IO context. Now, the actual purpose of this particular interface is really key here. What we're going to be doing is that if we wanted to hypothetically test any class which needs to use these coroutine contexts in a JVM environment, so not an actual running application, then what we could do is we could return a particular kind of coroutine context which allows us to test in that particular environment. I know that's a lot of technical detail, but I can't really make it a whole lot simpler than that. However, by using this interface here, when we want to use our coroutines in the production environment, we can provide the real UI main thread context for the front end, and then we can provide a real dispatcher for the IO thread. To make that even simpler, we're really just making the code easier to test. Right-click on the common package, go to New, Kotlin file or class. This time it's going to be an object, and hopefully I can spell this right, ProductionDispatcherProvider. Again, what we'll do is we'll write the code here, and then I'll explain how it works afterwards. I'm going to hit Alt-Enter again. And this is where we will return the actual dispatchers that we'll be using in production as per the name of this particular object. Now, there's a number of reasons why I'm using the object keyword here. So basically, objects in Kotlin are, in this particular case, singletons. So that basically means that we will only ever have one of these production dispatcher provider software thingies floating around in memory space at one particular time. They're also thread safe, which is important because although a coroutine is not necessarily a thread, our dispatchers.main and dispatchers.io has something to do with threading. And the other thing that an object can do is it can actually inherit from an interface. Now, we're not actually going to be writing any unit tests in this particular application which require the dispatchers, but just to show you what you would do if you wanted to unit test some class which needs to use these coroutine context, what you can do is you can just instead return dispatchers.unconfined, and then you would return that for both the IO context and the UI context, and then that is what you would use in like a JVM JUnit test environment.